In this video, you will learn to solve an equation by adding or subtracting. Now, before we get into solving equations, we first must understand a few terms. The first term is the word equation. What is an equation? Well, an equation is simply an expression with an equal sign. And we see the word equal kind of buried in the word equation, right? E-Q-U-A in the word equation. Just put an L right there, and you have the word equal. So an equation has an equal sign. For example, if we had x plus 7 equals 15, this is an equation because we have a mathematical expression and there's an equal sign connecting the two parts. The next word is the word solution. Now, looking at up here, this example of x plus 7 equals 15, we can replace x with the number 8. 8 would be a solution because we can replace x with number 8 to make a true statement, where 8 plus 7 is 15. So a solution is simply a value that can be substituted in place of the variable to make an equation true. And as we stated in that solution, that example up here, 8 would be a solution because 8 plus 7 is 15. Now, to solve equations, we first must understand the concept of balancing an equation. A simple way to illustrate this is thinking of a teeter-totter, or in other words, a seesaw. So here we see a teeter-totter where we have 50 kilograms on one side and 50 kilograms on the other. Okay, this teeter-totter is balanced because we have the same amount of weight on either side. Now, if you wanted, we could add another weight on this left side. Let's say we add 35 kilograms. To keep it balanced, we must also add 35 kilograms to this other side. So if we can add the same amount to both sides to keep this teeter-totter balanced. Now, same idea with an equation. We can add something to both sides of an equation, and the equation would still be true or balanced. So one thing that's allowed when you're solving equations is we can add the same value to both sides. Another thing we can do is illustrated here in this next picture. Let's say we have some unknown weight and 20 kilograms on the left side, and then 40 kilograms and 20 kilograms on the right side. To keep this balanced, let's say we took off the 20 kilogram weight. If we took off the 20 kilogram weight on the left side, we'd also have to take off 20 kilograms on the right side. So now this would be balanced because we have the same, we took off the same amount from each side. And here we see that this unknown weight would have to be 40 kilograms. So as we've illustrated, we can subtract the same value from both sides as well. In this case, we subtracted the number 20 from both sides. So when you're solving equations, we need to keep the equation balanced. And to do that, we can either add the same value to both sides, or we can subtract the same value from both sides. So what we're going to do now is we're going to walk you through several different examples where you must solve an equation by either adding or subtracting. So when you solve an equation, we need to keep the equation balanced. And to do that, we need to either add or subtract the same thing from both sides of the equation. And our end goal is we want to isolate the variable, meaning get it by itself. And we do that by performing the inverse operation. So let's take a look at example 1. Here we have x plus 4 equals 12. So what we want to do is isolate the variable, meaning get x by itself. Our goal is to figure out what is x equal to. So to make that happen, we must move this 4 away from the x to figure out what is x equal to. Well, we notice that the 4 is being added. The inverse operation of addition is subtraction. So what we do is we get rid of the plus 4 by subtracting 4 from both sides of the equation, which we see right here and right here. When we do that on the left side, notice we have 4 minus 4, which would cancel. That gives you 0. So you're left with just an x over here on the left side, and then 12 minus 4 is 8 on the right side. So our solution is x equals 8. And we can always double check our answer at the end, and we do that by plugging this number that we found back in for the variable. So if this is the correct answer, if we plug an 8 back in for x, we should have a true statement. So we plug 8 in for x to get 8 plus 4 equals 12, and that is a true statement. So therefore, we do have the correct solution. Here is another example. We have n minus 8 equals 15. So again, our objective is to isolate the variable, meaning get the variable by itself. So we want to get n by itself to have n equals something. Now to do that, we perform the inverse operation. So we need to get rid of this minus 8 by doing the inverse of subtraction, which is addition. So we must add 8 to both sides of the equation. And when we do that, when we add 8 to both sides, the negative 8 plus 8 would give you 0. So you're left with n by itself on the left side, then 15 plus 8, or 23, on the right side. So our solution is n equals 23. And again, we want to double check our answer by plugging in the 23 back in for the variable. So instead of n minus 8 equals 15, we now have 23 minus 8 equals 15. That is a true statement, which means we have the correct solution. Here is another example. We have 12 plus y equals 20. So this one, it may not be as obvious to you, but the 12 is being added. All right, so to isolate the variable, to get y by itself, we need to get rid of the 12, and because the 12 is being added with the y, we must do the inverse of addition, which is subtract. So we must subtract 12 from both sides, which we see here and here. Now we chose to subtract 12 because on the left side, 12 minus 12 would cancel out. You're left with y by itself, and then 20 minus 12, which is 8, on the right. So we have, should be not n, but y. Y equals 8 is our solution. Now we can double check our answer by plugging the 8 back in for y. So instead of 12 plus y, we now have 12 plus 8 equals 20. That is a true statement, which means we have the correct solution. Now one thing I want to point out here with this example, with 12 plus y equals 20, if you're struggling to see why the 12 is being added, it may be helpful for you, possibly, if we change the order of the addition. Remember, with the commutative property, we can change the order of addition, right? So instead of 12 plus y, we could say y plus 12 equals 20. That is the same thing. So if it's helpful, you can rearrange like that. And from here, it might be a little more obvious that the 12 is being added. So then we must subtract to get rid of the 12. But either way you want to think of this, you would subtract 12, and your solution would be 8. Next example, we have b plus 8 equals 3, and you are to solve for the variable. So again, we must isolate the variable, meaning get b by itself to figure out what is equal to. So to do that, we must get rid of this plus 8 by doing the inverse operation. The inverse of adding 8 would be subtracting 8. So we subtract 8 from both sides of the equation. On the left side, 8 minus 8 cancels out. You're left with 0, b plus 0, or b. And then over here, on the right side, 3 minus 8, that would give you negative 5. So make sure you know how to add or subtract with negative numbers. But when you subtract 3 minus 8, it's going to be negative 5. And we can double check our answer by plugging the negative 5 back in for b. So instead of b plus 8 equals 3, we would now have negative 5 plus 8 equals 3. That is a true statement, which means we have the correct solution. Another example, we now have m minus 4 equals negative 7. To solve this, we want to get the variable by itself. We want to isolate it. So our end goal is to get m equals something. Figure out what is m equal to. To do that, we perform the inverse operation, and the inverse of subtracting 4 would be adding 4. So we have to add 4 to both sides of the equation, and when we do that on the left side, negative 4 plus 4 would cancel. That gives us 0. So we have m plus 0, or just m by itself. And then on the right side, make sure you can add and subtract with negative numbers. And assuming we can do that, we have negative 7 plus 4, and that would give you negative 3. So our solution would be negative 3. And again, we can double check our answer by plugging the negative 3 back in for m. So instead of m minus 4, we have negative 3 minus 4. So negative 3 minus 4 equals negative 7. That is a true statement. So therefore, negative 3 was the correct answer. Another example, we have negative 4 plus h equals 9. So for this one, again, we want to get h, the variable, by itself. We want to isolate it to get h equals something. Now to do that, we want to get rid of this minus 4, or negative 4. So we need to do the inverse operation. This one, you can think of the minus 4 as subtraction of 4. If you can't visualize that, you could rearrange the order of the addition, like we did in that other example. So instead of negative 4 plus h, we can have h plus negative 4, which plus negative 4 is the same thing as just h minus 4. So either way you want to think of this, our end goal is we want to add 4 to both sides to undo the minus 4. So to get rid of the minus 4, we do the inverse, which is adding 4 to both sides of the equation. So looking over here, we add 4 to both sides. Negative 4 plus 4 would give you 0. So we're left with h on the left side. And then 9 plus 4 is 13 on the right. And we can verify that we did it correctly, because if we did it correctly, when you plug 13 in for h, we should have a true statement. So let's try that. We have negative 4 plus, instead of h, we have 13 equals 9. And that is a true statement. So therefore, we do have the correct solution. Next example, we have a decimal thrown in here. So we have 1.2 plus x equals 17. So if it's helpful, you could rearrange this. Instead of 1.2 plus x, you could put x first to get x plus 1.2 equals 17. You don't need to do that, but you can if you want. And either way you want to look at this, we have a 1.2 being added. So to get rid of the addition of 1.2, we do the inverse operation of adding, which is subtracting. So we subtract 1.2 from both sides, which we see right here. And when you do that, the 1.2's cancel out. So you're left with x on the left, and then 17 minus 1.2 on the right. So we're assuming you know how to add and subtract with decimals. And when you subtract 17 minus 1.2, just make sure your decimal points line up. You'd set it up like this, and you have to borrow from the 7, that becomes a 6, and the one you borrow goes right here with the 0. So now we have 10 minus 2, which is 8, 6 minus 1 is 5, and then we have 1 in the front. So our final answer is going to be x equals 15.8. And we can double check our answer by plugging in 15.8 back in for x. So when we do that, we now have 1.2 plus 15.8 equals 17. If you add those together, 15.8 plus 1.2, we'd have 10, carry the 1, 7, and then a 1. We would have 17 as our answer. So that works out, which means we do have the correct solution. One more example, and here we are dealing with fractions. So for this one, we have b minus 7/8 equals 5/12. Now, even though we have fractions, our steps will be the exact same as without fractions. and we need to get rid of the minus 7/8. We want to isolate the letter B to get it by itself. Well, to do that, we do the inverse operation. So the opposite of subtracting 7/8 would be adding 7/8. So we must add 7/8 to both sides of the equation to keep the equation balanced. And when we do that, we're left with B on the left, because the negative 7/8 and the plus 7/8 would cancel. And then on the right, we have 5/12 plus 7/8. Now we're assuming we know how to add or subtract fractions. And this one, we need to find a common denominator. So looking at the 12 and the 8, multiples of 12 are 12, 24, etc. Multiples of 8 would be 8, 16, 24, etc. Notice they both have a common multiple of 24. So I'm going to rewrite the 5/12 as something over 24 and 7/8 as something over 24. So we look at the bottom of the first fraction. 12 times the 2 would get 24. Do the same thing on the top. 5 times 2 would be 10. Other fraction, 8 times 3 is 24. 7 times 3 would give you 21. So what we have is 10 24s plus 21 24s, which would give us 31 24s. And we're going to leave it like this for now. This is our answer. We could write this as a mixed number. But when you check your answer, it's going to be helpful to plug it in with this instead of a mixed number. So if you plug 31 24s in for B, we can check our answer to see if we got it correct. And we have 31 24s minus 7/8 equals 5/12. We need a common denominator of 24. So 7/8 we already said was 21 24s. And then 5/12. 12 times 2 is 24, so 5 times 2 on the top would give you 10. You have 10 24s. So is this a true statement? Well, yes, because 31 minus 21 is 10, so we have 10 24s. So we verified that 31 24s is our solution, and if you want, you could rewrite this as a mixed number. You divide 31 by 24. 24 goes into 31 one time with a remainder of 7. The remainder you can write as 7 over the 24. So your solution is 1 and 7 24s, or 31 24s. And that concludes our lesson for today. We will see you next time.